Okay, so this is an re-recording, so I will be doing. Okay, so this recording will be for the day 2 and the day 3, which I could not be able to do it because of some technical issues and where my recording software was crashing, correct? So I am re-recording it. So coming back to the syllabus, correct? So I started my second day with giving very high level about the syllabus part, correct? So in this syllabus part, so what yesterday in the day 1, what we have covered is okay. Yesterday in the day 1, what we have covered is the introduction to the IoT and the energy management, right? Now, so what we have learned is we learned the fundamentals of the IoT, and we also learned about the architecture part. So better like I will open the slide for the better understanding, right? Yeah. So this is one thing we learned, right? The architecture and the role of the sensors, actuators, and the controllers in the energy system. So we spoke about these 5 layers of the architecture, right? So in that we had the layer 1. It is all about the device layer where we have the sensors, the actuators, and the controllers, right? So these are all the sensors which will be in the field or inside the building, which will be spread across in the various locations. So these are all the device which help us to get the parameters, right? So these are all the sensor, actuators, and the controllers that falls under the device layer. Then we spoke about the transport layer, right? So that is also known as the network layer. In this network layer, it's all about the IP protocols, because these sensors or like actuators, what we will be using in the field, right? This is, it needs to be in smart, and it has to communicate with each other and also with the server, right? So to have the communication, every sensor and the actuator should have the unique IP address, right? So once it has the IP address, then only they can able to talk to each other in the network, right? That is about the transport layers. Now, and the third layer is the edge, the processing layer, right? So this is what we learned in the day 1. In the edge or like the processing layer, what we have is the gateways, right? So in the device layer, so actual physical sensors will be sending the data to the network layer and the transport layer, and then that data will be moving to the processing layer. So it could be sending to the cloud, or else we can able to compute in the edge. So if we have the servers within the facility, then we can able to use that servers to do the local compute. Okay, instead of we sending all the data to the cloud, we can able to do that in the layer 3. So let's say we don't want to use the local compute, and in that case we have to use the gateway. So what this gateway will be doing is, so this gateway, it will send the data. Okay, so this will send the data to the cloud. So this gateway could be an MQTT, right? So this we learned in the module number 3 in the detail, and also in this specific module also we will be going in in depth, in the more depth about the MQTT, because the syllabus calls for the detailed explanation about the MQTT and other similar communication protocols. Okay, that's one thing. So that is all about the layer 3. That is the edge and the processing layer. Now what will happen is, so let's assume we are using the gateway, and from the layer 3 we will be pushing the data to the layer 4. Layer 4 is all about the cloud. Okay, so as I mentioned earlier, we can able to do it locally, that is called edge computing, or else we can able to filter it and use the gateway to send the data to the cloud. So the layer 4 is all about the ingestion, okay, and the storages. So here in the cloud, so I will be taking an example of the AWS, correct? So in the AWS, so we have to use IoT core as in gateway, the plus S3 bucket for the storages, or we can able to use the DynamoDB. So this DynamoDB is a NoSQL, right? SQL database. Okay. The good part about the DynamoDB is, so this is the key pair value. Database. Okay. Why this is more make sense? Because the most of the data, that is the sensors or IoT devices, what we will be using, correct here. So everything will be in the JSON format, like so device ID, some value, and the parameters like the power should be some value, and the voltage some value, and the current the some value. So these are all like it will be in the JSON format. Okay. So this is the key pair. If you see here the device ID, it will be paired with an value, right? So this is called as the key pair. So it is whenever we use the DynamoDB, it is very much easy to save this key pair value into this NoSQL DynamoDB, correct? So this is the specific reason we will be preferably DynamoDB. There are other ways to do also, right? That is one thing. So, and S3 is all about the storage. So S3 is about the storing the raw data. If let's say we can able to save the data directly to the S3 bucket as in JSON, and then use this data for the further processing. That way also we can able to do this, because S3 is then the bigger object level storages, right? So once we have done this, we can able to do the further processing. So everyone needs to understand what exactly the cloud injection and the storage is. So this is one of the example. Okay. Now, so we saw up to layer 4, correct? Now, the final, the top layer is all about the analytics. So whatever the data we are ingested into the cloud, and basically we are storing that data, correct? Once we store that data, we have to do some processing, or else we have to get the insight out of this storage. What exactly we will be doing from the data? So we will be doing some analytics. So that will be related to the business. So it could be, we can able to do some ML model, that is the machine learning model. Okay. And we can able to create our own dashboard where it will be an decision making dashboard, right? Let's say let's take an example. In this specific floor, if we have the less occupancy, right? Let's say this is the floor, one single floor, and we have very much less occupancy. and every day there will be an very much less occupancy for the 1 or like 1 month of duration. So based on these historical data, which will be stored in the S3 bucket, the decision maker can able to directly see in the dashboard and say, okay, this specific floor having very much lesser occupancy, and they can able to take the decision telling that we can able to cut down this floor, we can able to rent out, or else we can able to shut down this specific floor so that they can able to save some cost, right? This is how business decision making will take place, right? This is one thing. Now again, it is also related to the billing, right? So how we can able to relate the business analytics to the economics, that is in terms of the money, correct? How we can able to save the money and do some the good investment, so that is related to the business. Okay, so that is where the layer 5 is all about. So in the day one, we learned about this layers. So whenever in the exam, okay, there was some technical issues. Okay, and I was talking about this. Whenever we asked certain the questions in the exam, correct? So let's say uh, in an exam we will ask to define an the layer, the reference architecture for the the smart building. Then you have to mention these 5 critical layers. Okay. Now, this was the day one. This was just an the high level, and also what we have learned is, so we also spoke about how we can able to extract the telemetry data, how the actuators will be helping us to break or make the complete circuits, and what are all the different the protocols also we have learned. Right, we saw the Modbus, the DNP3, IEC 61850, and so on. So these are all the the communication, the protocols which we have already learned in the module number 3. Okay, and I also mentioned we will be learning about the long range, the WAN, this specific one, and also the Wi-Fi. Okay, in the day one, and also in the day one we spoke about MQTT, which is the pub sub, and we also spoke about the comparison between the CoAP, the newer one, HTTP, and so these two protocols and even the MQTT will be studied in depth. Okay. And we also spoke about how the edge processing will happen and so on, right? So directly coming to the day 2 subjects, correct? Now, so for the day 2, what we will be learning is we will be learning the major important technologies. Okay. So one I will be introducing to you guys is the KNX one. This is not only specific the communication protocol, it's by itself, it is a technology. Okay. Okay. You have to, make sure that you learn this KNX, because this is the one of the latest and widely adopted the technology in the BMS system. So that is building management system, and also energy management systems, the IoT systems, and so on. So if you see this is best for the complete whole building infrastructure. Okay. And how it is connected is it is connected via the bus. So I will be explaining completely in the depth how the architecture part. Okay. But before we going in depth, you need to understand what exactly these technologies are, at least in the basic, and what are the different technologies we will be having, right? And the good part about this KNX is it's an open standard. So when we say the open standard, it is not only not limited to any specific OEMs or else like any specific uh, the standard, right? So it will be an open standard. Anybody can able to use this to design complete the energy management system and the BMS system. Okay, that is one thing. That is the main important. So the first we'll start with the KNX, and the second one, it is another important one is the backnet. So this is also another very, very important the technology. So this will be this specific backnet will be implemented most of the case in the HVAC. So HVAC is like heating, ventilation, and the air conditioning. So in the smart building, so this is also one of the key parameter, right? So we need to regulate the airflow, air temperature, so and on. So along with this, we also need to regulate the electrical, the appliances within the building when we are designing a smart buildings, right? And so the specific the backnet, it is best suitable for HVAC and the large commercial BMS, that is BMS, building management systems. Okay. Now, coming to the connection types. Okay, the so connection is again it will be wired, but it will be on the IP. Okay, here in the KNX there is special architecture where we will be using the bus, not the IP. So we'll get to know what exactly the bus is. Okay, again this open standard. Again, this is an open standard. So anyone who wants to design the complete the commercial BMS system, right? Again, they can able to use this, the backnet. Okay. And other two. So this is also the the important the protocols, right? Zigbee. Most of the you people have heard about the Zigbee, right? So why this is used? See, this is implemented where we need the technology for the low power wireless sensors. So for example, the battery operated sensor, which is relying on the battery, and so we need to make sure that the battery is not drained at a faster speed, correct? So in that case, what we will be doing is, so we will be implementing the Zigbee. And coming to the wireless, so and the connection type is the wireless, okay? And it will be a complete mesh. So when I say mesh, it is like we have then sensor A, sensor B, sensor C, D, and E. So this wireless mesh, it helps in establishing the connectivity from the A to B, A to B, A to E, E to D, and D to C. And so it will be complete, the connection between all the sensors. Okay, this system is called as a wireless mesh. Again, this is an open protocol. Okay, this is the Zigbee Zen protocol. Okay, now the last one, what we will be studying is the long range wide area network. Okay, this is implemented when we want to cover very large area, right? So this is in terms of we want to create very large smart city where we don't want to lay the wire cable. So usually we use RJ45 cables, correct? So you don't want to use this cable. Instead of that, you want to use the wireless Wi-Fi. So when we want to do this, we always go to the long range wide area network. So the best use case is for citywide smart metering. Okay, one thing. And the connection type is, as I said, it will be the wireless, that is the long range, not the short range. So usually it will be an industrial grade outdoor. So like the Wi-Fi, we call it as access points. Okay, for this we call it as access points. So this will be type of outdoor industrial grade. Okay, because most of the cases, these access points will be installed at an open environment. So usually we need to have the IP68, the rating. It is and dust and the water resistant, the IP rating, correct? Ingress protection rating. So because of that, we always tend to choose the outdoor industrial grade access points. Okay, again, this is an open standard. So this is all about the technologies what we will be learning in the module number 4. Okay, so yes, so let's start with the KNX, and then we will talk about the backnet. But the Zigbee and the long range WAN, so we will just touch base. We will not go into the depth in terms of architecture. Okay, so only the KNX and the backnet, and so there will be an assignment based on the KNX, even the backnet. So make sure that you understand what exactly the KNX is and the backnet is. Okay, right. So let me stop sharing. Now let's start with the KNX. Okay. So now let me open that KNX. Yes. Let me share my screen. Okay. Great. So let me go back here. Great. So what exactly the KNX is? So the KNX, it is based on the ISO IEC, that is 14085. 543. So this is the words only open source in terms of the building automation and the energy management. So which is widely recognized and utilized for the decentralized smart home and the building controls. So there are other open source, but so this is the key important where the KNX stands out, where it has the architecture where the decentralized smart home, the building controls are the key fundamental of the architecture part. Okay. So again, if anybody wants to learn more into the KNX and its standards, correct, you have to download this specific the standard, that is ISO IEC 14543. Okay. And again, coming to the architecture point, right? So in the module number 3 also, we have seen the SCADA system, right? The most of the part was the SCADA system. In the SCADA system, if you remember, we were discussing about the, the model, the layer model, right? So we had 5 different layers, right? So we had device layer, the transport layer, the application layer, and so on. So in the similar fashion, so in the module 3, what we are learning now is, in the module 4, what we are learning is, we are learning the KNX, right? If we wants to define the architecture part, right? The standards. So even it follows the similar, the OSI model, right? We OSI model as the 7 layers. And so this specific KNX also almost it is similar to the 7 layers, and we will be going in the depth, and only there will be little changes wherever needed. Now the point here is, instead of 7 layers, there will be 5 layers, and this specific KNX, it is used for then high reliability. And also that is one key point, and the second key point is for the low bandwidth. Okay. Right? Okay. So these are all the 2 key important why we need to select the KNX as an energy management, the protocol technology, and the BMS for the BMS. Okay. Let's understand what makes this KNX differ from the other protocol, and why it has been very much widely adopted in the latest building management systems. Okay. So now if you see the older models, older technologies, it's all the centralized controlling, and all the other IoT devices will be connecting to this specific centralized control, and centralized controller will act as the brain. Okay. That is all about the legacy system. Now, so you see here, the device act as a dumb terminals relying entirely on the central servers. So this means even though IoT device, so it will be having the minimal the intelligence, so it cannot able to take the decision by itself. Okay. So what smartness this IoT device will be having in the legacy system is, so it will make sure that these IoT devices, the hardware, it is sending the data to the brain. Okay, that is central controller. So it doesn't mean like so it is completely dumb. No, it will be having the small amount of intelligence, but it cannot able to take the decisions. If the central controller fails, then complete the system. So if we have the multiple, the IoT is integrated and it is tightly coupled, correct? So complete system will fail. So how do we mitigate this single point of failure? The only thing, only one way we can able to do it is decentralizing it. Okay, if you see this specific architecture, what we will be studying now, correct? So in this architecture, that is KNX architecture. So every sensors and the actuators contain its own micro intelligence. Okay. So this is the very key important, the point in the KNX. So whatever the device we will be selecting, correct? So these devices, so there are like different manufacturers, they manufacturers these, the sensors and these devices. So the famous one is the Snyder, the other one is like we have the ABB and so on. So these are all the then a key original OEMs, that is manufacturers. So they produce the devices which is compatible with KNX and which will be having the micro intelligence within the sensor device itself. Okay. Now, and the second part is, so devices, they communicate directly via shared medium. So no single point of failure. So this is the key point here. So the KNX, so you can able see this is one of the IoT device. This is other IoT device, and this is another IoT device. So these devices are interconnected. Okay. And even though if this fails, other systems will be still up and running. Okay. There is no single point of failure here. Correct. This is what we need as an reliable system. So if we are designing any system which needs to be fail proof, correct? So we should not have the single point of failure. So if you compare to the legacy system, in the legacy system, we will be having the centralized control, correct? So even though in the centralized controller, if we have the backup as in like high availability, then we can able to achieve the resiliency, but it will be an the higher cost. Still, the IoT device will not be having this intelligence. Okay. Okay, this is the basics about the KNX devices and the architecture. Now, so I was mentioning earlier, right, the OEMs. Here, let's, okay. So this is an open standard. And if you see, it is interoperable ecosystem. When I say interoperable, that means if you're selecting any of the device from any of the OEMs, that is original equipment manufacturers, these devices can be integrated as in single systems. That is called interoperability. Okay. So that is the good part about this. Now coming to the OEMs. So in the coming to the native OEMs, when I say native, these are all the OEMs specifically. They will be manufacturing their devices for the KNX, right? We have the Jira, we have the ABB, and these two are the very famous OEM. What is the role? So these OEMs, they provide the core architecture, so including the power supply, the actuators, and interchangeable design lines for the physical switches. So we will see what exactly these components are in the design slides. But yes, so whenever we are choosing these OEMs, correct, the ABB, Schneider, and other famous OEMs, they will provide the complete set, right? So only what we have to do is, as an the architects, we have to choose how much the power we need. We need to estimate the power, and we need to select the actuators, what the size of the actuators, right? And the line remain the same. So only our part will be just to select the proper devices based on the requirement. Okay. And coming to the specialized OEMs. So when I say the specialized OEMs, let's say you are designing an smart building where you are more focused into the HVAC, that is heating, ventilation, and the air conditions. Okay. And then you are more focused in terms of the security. Correct. So how do we do that? So we can able to choose either the native OEMs, that is also fine. You can able to do it. But if you want specialized in these two areas, then either you can able to use the Daikin and the Bosch. So the Daikin is very much famous for the HVAC one, and the Bosch is very much famous for the security part, right? So this is where the specialized OEM comes into the picture. Now, and there is other third OEMs, which is called as like, the white label OEMs. So this is a generic one. Okay. So when I say white labeling, so these OEMs will not have their own R&D, or else they will not be having any of, the specialized one, but it is a generic one. So what they will be doing is they will be, getting the technology from the other OEMs, the parts, and they will fit and they will rebrand their own product. Okay. So whenever you want an cheaper or is like less economical design and the products, then you can able to choose the white labeled OEMs. So even though this is white labeled OEM, this perfectly works on the KNX technology. Okay. KNX one. And that is the one. Now, if you see this part, okay, the greater equalizer. So regardless of origin, every device undergoes strict KNX association certification for the guarantee perfect interoperability. This is what the KNX promises. The technology, the KNX technology for the building management system, right? So it will ensure that whatever the system design, what we will be designing with various OEM, so complete the framework, the KNX framework, make sure that it operates, the complete system operates as per the expected results, what way we are expecting. So it will operate in that case. Okay. This is all about the introduction to the OEMs and so on, right? Okay. Now let's move to the next slide. Okay. Here. So yeah. We, in the module 3, we went in the depth and understood what exactly the OSI model is. So OSI model is basically the network model, correct? So usually if we are wanting to connect the laptop to the server, or else like any of the client to client, client to host, these kind of communication, if we are requiring, then we always go for the OSI models or TCP IP model. Okay, so OSI is like pretty old, and this is called as a very base the framework what we will be using. So in this OSI model, we will be having the 7 layers. The first layer, the physical layer, where all the physical part, the cabling part, the router, not routers. So usually this is in terms of the cabling. Okay, then we will be having the data link, and again the network in the network layer. So in the data link, it is the switches to transport in the packets, and again in the network we have the transport layer in the layer number 4, and the 5, 6, 7 almost belongs to the application. So this is the application where we will be opening the session, the presentation application, that is HTTP will be sending the request down the line, and in the receiving end, it will go to from bottom to the top, correct? In the TCP, we always use either, in the transport layer, we always use either TCP or the UDP, okay? In the network layer, it is all about routing, that is IP. Okay, everyone needs to know what exactly these are, because this is the core concept, the basic concept, which we need to understand when we are designing any of the latest technologies, right? In this is OSI model, and now, so what KNX has done is KNX has adopted this, but they have simplified it. Okay, so in the KNX, what we are having is we have the stacks. It is 5-layer stacks. One is the KNX. Again, this is almost similar to the layer number 1, that is the physical, where we are getting the data of like voltage, the cabling and the modulation and so on. Correct. This is in terms of the physical one. And coming to the layer 2, that is the data link. Here we always talk about the SES&SE, that for the error checking, and we'll talk about that. And it is all about the data link. Okay. For the medium access. Now, coming to the layer 3, it is the networking. I was talking about the OSI model also, right? In the similar fashion, in the KNX also, in this layer number 3, it is all about the routing between the line and areas via coupler. This is the major difference. Okay. In the OSI model, it's about one router to other router, correct? If we have the two routers, the router 1 to router 2, how the router 1 and router will be reaching, we will be establishing a routing protocol, BGP, and so on. Usually, if we have the different areas, correct, area 1 and area 2, we will be using the BGP to establish and routing to exchange the route between the two routes, and the communication will be established. In the similar fashion, in the KNX, we always talk about the routing between the lines, that is in the different areas via couplers. So we will be seeing how these couplers will be utilized, right? Okay, that is one thing. And coming to the layer number 4, that is all about the transport. Okay, so what exactly this transport is? So this transport is the end-to-end data integration and the segmentation. So whatever the data which we have received from the layer 1, 2, and 3, correct? So that needs to be sent to somewhere for the further processing. So that will be taken care by our layer 4, that is transport layer. Okay. Now, the layer 6, 5, and 7, almost similar to the application, where we will be utilizing the application layer for the processing of these data, or else to generate these data. So this is pretty much clear, right? So basically, the KNX is in 5-layer stack, which is the adoption of the OSI model. Okay, and yes, this is suitable for the low band control data. Okay, great. Now, let's see the actual design. If we are planning to design any system, correct? So we need to know how we can able to design and complete smart building. So here, if you observe very carefully, so we have the 3 different layers, right? Let me. So we have the layer number 1. You can able to see here, right? And we have the layer number 2. And we have the layer number 3. Okay. Now, so layer number 1, it's all about, it is called the line. What exactly the line? So level 1, it is in structure. Okay. A single segment of the twisted pair cable. So it is a physical cable, twisted pair cable. The copper cable, we will be utilizing it. What it will be doing is it will try to carry the current as well as the data. Okay. And this is one thing. And now you can able to see the different devices connecting to this. These are all the IoT devices. Okay. So when I say IoT devices, these can be the thermostats. These could be the controllers. These could be different, the motion sensor, the light sensor, the fan controllers, and so on. It could be any kind of IoT devices. Okay, so these IoT devices will be connecting to this, the bus. I mean the line. Okay, this is the copper line. And you may ask how many devices we can able to connect to this single line. So we have the limitation up to 64 devices. That is IoT devices. 64 smart devices. Okay, this is one thing. Now, this the line, it will be connecting to the line couplers. Okay, what exactly these line couplers will be doing is, so line couplers, it acts as a localized firewall. Okay, you see, these are all the line couplers, and what this will be doing is, so this will be help us in the filtering the telegram. So telegram is kind of the packets. It is kind of, you think like an analogy, it is kind of the packets. What it will be doing is, they will block the local traffic flooding the backbone. Okay, so we have this backbone, correct? This is the main important backbone which will be carrying all the data from the different areas, and it will be aggregating this, the device information, to the backbone, right? So what if like unnecessary data is feeding to this backbone? So one thing, we are choking the bandwidth, and we are underutilizing the bandwidth. It in the sense of efficiency. Okay. So for that reason, we are utilizing the line couplers. Basically, it will act as an local the firewall. Okay, that is one thing. Now, in the similar way, you can able to see here we are connecting one line here. We can able to have the multiple lines. Okay, this is line number 2, and this is line number 3. So all the lines needs to be coupled with a line coupler. So we cannot able to connect directly the level 1, that is the line directly to the level 2, that is main area line. Okay, we cannot do that. Okay, as per the framework and the design standards, we need to have the line couplers at the end of every line from the level 1. Okay, that is all about the level 1. And now, so in the level 2, that is the main area line. So what it will be doing is, it will collect all these, the lines. Okay. So how many number of lines we can able to connect? It is about 15 couplers. So now assume this is a first coupler, this is second, and this is third. Okay. In similar fashion, we can able to have the couplers up to 15. Okay. Now, it is the maximum. We cannot add 16 because there will be the voltage drop and the current drop. There will be a parameter mismatch. So as per the standards, we cannot exceed the 15 count. Okay. That is one thing. Now, if you see this, again, the couplers, these are all called as area couplers. This is the area number 1, area number 2, and area number 3. Okay. So what this will be doing is, it will collect the different main area line from the different level. Okay. Up to 15 areas we can able to connect. Again, 15 areas. Again, these areas will be connected to the main backbone, and backbone will be connecting to the different that backbone will be connecting to our server, main server, where the detailed analysis and the controlling, the feedbacks, everything will be taken care. Okay. So this is how in the actual scenario it will be working. Okay. So this looks simple, and only the critical and the tricky part is selecting the proper device with the proper parameters. The voltage, current, and the power, the parameters is what we need to do it, and we need to keep in mind what is the limitations when it comes to the number of device per line per area and the backbone limitations. Correct. This is what we need to understand. So I hope this is pretty much clear, right? Okay. Yeah, and one more thing is in the backbone we use the IP, uh, right? KNX net is what we will call for the communication, and this happens by through the twisted pair. Okay. Yes. So in while explaining the architecture part, so I was telling the standard limitations, correct? So see here, like the maximum device per line, it is 64. Okay. And this can be increased to 256 by adding extended power supply. I was mentioning earlier, right? So we cannot able to extend the number of limitation because we may see the power drop. Okay. If longer the length, there will be obviously power drop will be there, correct? For that reason, we cannot extend more than 64 devices, right, per line. Now we can able to extend by adding the extended power supply. So this will be kind of the boost, powering boost. So this will help us to increase the power, uh, the the power flow in the line so that it can able to power the additional IoT devices. That is like end devices. Okay, one thing. And yes, again, there is like the 15, the maximum lines we can able to have per area, and the maximum area is 15, which we already discussed, correct? Now, if you calculate 15 areas maximum theoretically and 15 lines with 256 devices, right? You can able to see up to 50, nearly 57,000 devices we can able to design based on the KNX in the single. So we can able to have the multiple, the frameworks or like design of this, but in a single the KNX design, we can able to go up to 57,000. So you can able to imagine the scale. We can able to design complete and the skyscraper with the 57,000 devices, and we can able to operate. We can able to send the command within a millisecond. So that is the power of the this KNX in the building management systems. Okay. And coming to the length, okay. So we got to know like we have the limitation in terms of power supply. Now we also have the limitation of the length. So length should not exceed 1,000 meters. Okay. The maximum twisted pair cable for the individual line segment is the 1,000 meters. We should not extend this 1,000 meters. And for the maximum power proximity, it is 350 meters. Okay. After 350 meters, we need to add the additional power supply. This is a key factor. And why I am just going in the depth, because if you wish to create your own project or like any portfolio for your resume, or if you want to establish or else publish any of the the papers in any of the journal, correct, you can able to use this as an basic. On that you can able to build your own case, right? For that reason I am going in the depth in the designing part. Okay. Now coming to the cabling part. So this is the green cable. We also call it as the twisted pair cable. Okay. So this will be having the the two pairs, like so we will be utilizing that to deliver both the power as well as the cable, this data. Okay. When it comes to the power, it is the 29 volts DC. It is not the AC one. And when it comes to the range of power, it could be 5 to 20 milliampere only. Okay, so this is per device I'm talking, not the complete device. So this we can able to send the power. Okay, and coming to the data sampling, we can able to do up to the 9600 bits per second high frequency data signaling. So these are all the signals which will be used to communicate different the end devices, and these devices can able to communicate to the servers and get the command to operate as expected, or like switching on or like switching off in the basic terms, right? So yeah, and it is combined both the power as well as data. Now again, there will be a problem, correct? So there will be a problem of EMI, that is electromagnetic induction. So this will occur like, so whenever we choose the cable, we need to make sure that the EMI is very mitigated when we are transmitting both the power and the data in the same line, correct? So in this specific twisted pair cable, so it has been addressed, okay, as per the KNX standards. One thing. Now coming to the power supply, okay, now the power supply unit. So basically this power supply unit as a standard, it will provide the 640 milliamps power. Okay, and this can able to the power up to 64 devices, because per line we can able to have the 64 devices only, right? Again, so you can able to see there is one inductor choke. Why we are utilizing the inductor choke? So the choke, the inductor is placed in series with the power supply. So why we need that? Because they present high impedance to the high frequency data signals, so that we can able to prevent the data loss in the power supply, right? For that reason, we always use the inductor in series with the power supply in this specific KNX framework design, right? And again, one point here is, like, if you see the thickness of this the cabling, it will be 18 gauge cable. Okay. Oh, this is all about the TP cable, so which tends to deliver both the power as well as data simultaneously. Okay. Right. Okay, to continue with, so we saw the twisted pair, correct? So it is, we need to have the different, the components, that is the physical components, correct? So one is, we already saw that we have the twisted pair, which is then dedicated, the green cable. Okay, and the other one we need to have is the KNX net or the IP, that is the Ethernet one. Okay, and what it will be doing is we will be having this RJ45, right? So Ethernet cable, though that will go to the servers or any of the computer system where we'll be installing that the server, which will be getting the all the details of the end the devices, that is IoT or the smart devices, correct? And so to have this communication, to enable this communication, so we need to have the KNX net IP. Okay, so that will work on the local area network, wide area network, or the UDP packet. Coming to the use cases where we need, we obviously wherever we need the high speed, the backbone connection, right, within the building, also within the floors. So this is where we need to use it as for the backbones. Okay. Now coming to the power line. So the power line is called as KNX PL. So the data is called as KNX net IP, that is basically an Ethernet only. And here KNX PL, it is the power line. So it it will be utilizing the 230 volts or else like 110 volts from the main. Okay, and so this is compatible as per the latest requirement, as per the building compliance one. That is one thing. Now, in the other case, you are seeing the radio frequency, correct? Now, if we have the use case where we cannot able to lay the cable from one end A to end B because of some space constraint or like because some retrofittings, historic retrofittings, or else glass walled architecture where we cannot able to puncture or cut that specific the glasses or like specific infrastructure, correct? How do we do that? So in that case we can able to use the radio frequency one. So even the KNX will support the radio frequency at this specific hertz. What we have to do is we need to have the transmitter at the one point and the receiver at the other point. Okay, so the transmitter end always transmit the signal wireless, and the receiver will receive the signal, and the communication will establish, and the packet will be sending and receiving in the bidirectional way. Okay, so this is all about the adopting the physical layer in the KNX design. Okay, and the coming to the very important the part, that is the addressing. Okay, so every device, so I was mentioning earlier, right? So every device within the KNX need to have one address. So how it will be? So there will be an physical address. So that will be in the format of like this. So here we have given 1.1.5, correct? So this is nothing but the area, the line, and the device. So this makes us to differentiate every devices, and this will be having the unique address so that it can be able to easily reach from the server, and it can able to communicate to the server. Okay, so what the physical address on this format, the area, the line, and device will define is it will dictates the exact hardware location on the bus. Okay, obviously because every hardware will be having the different address, correct? So based on that we can able to reach and specific the device on the specific line. So that is the key important one. So yeah, so that is why we need the physical address. Now coming to the other part, so we also have the grouping address. You can able to see in this side, correct? It's a grouping. So even that will have the similar format, but only difference is, so this will have the dot. Okay, this will have the dot, and this will have the forward slash. Okay, and the format is the main, middle, and the sub. When we give some number, so that means we are logically grouping the physical devices as a group. What is the good part about it is, let's say we have the living room lightings, or else we have the conference room at every floor of the building. So you can able to club it, and we can able to group as an conference room lighting in the single group. And whenever you want to push something, some notifications, or else some commands to these devices which are present in that specific uh, locations, right? The conference room, at in the bulk we can able to push it, instead of we logging into the each devices or as each room and sending the signal or the command. We can able to bulkily do the operation by using the group addresses. Okay. Yeah, used continuously for the daily event driven operations. Okay, enable one to many controls. So we can able to send one signal to the multiple receivers when we have the group address. Right, and concurrently triggers the multiple distinct actuators. Okay, so this is one of the key the parameters we need to keep in mind whenever we are designing KNX based building management system, that is physical address and the group address. Okay, now here let's say we have an event which is generated from the device, end device, that is, let's assume like we have the temperature IoTs which is connecting to the one of the specific line at the level 1. So what if all the 64 devices start communicating? Okay, when it starts communicating, there might be in chances of the collision, right? For example, let's say we have the A sensor, B sensor, and C sensor. At a given specific time, if all the sensors are transmitting the data to the line number 1, then there might be a problem. There might be a problem of collision, correct? How can we avoid this? So whenever there will be a collision, there is a loss of packet, and the device may not be able to communicate to the server, or server can also not be able to communicate to the IoT devices. So to avoid this, what we use is we use CSMA and C. So this is called as carrier sense multiple access with collision avoidance. So this is one of the key thing which is adopted in the KNX framework. How it will be doing is, so it always in the listening mode. Okay, so device will be device monitors the bus for any idle state. It will be keep on listening mode, then it will wait. If idle, wait a random short interval to prevent simultaneous transmission. Okay, even though we are not sending any data, still it will have the predefined wait, the minute, or else in the seconds. It could be in the seconds. Usually it will be in the seconds only. Then after the wait, there will be a transmit command. The transmit, what it will be doing is, the device will send the telegram, that is the data on the one state. No continuous polling the overhead. Okay, after the transmit is triggered, that will go to the collision check. What the collision check will be doing is, so it will be keep on checking the factor that, like, if two devices transmit, then there will be high chances of corrupting of that specific signal or the packet, right? So This collision checks instantaneously stops that. Okay, and in the next part there will be a random back off. So random back off is like the system will wait for few seconds. Okay, and then again it will start to generate the period before re-entering the listening phase. It will wait for a certain predefined time, then again the cycle will continue, so that this process will help us in the non-collision and the clean the architecture where the system can able to communicate with the server as well as the IoTs seamlessly, right? If we have the collision, then high likely we may lose the packets and the signals. So for that reason, whenever we deploy this KNX, right, we have to make sure that we implement CSMA and the collision avoidance. Okay, that is one thing. Okay, now coming to the important part, the structure of the telegram. Okay, so this KNX is of 20-bit control telegram. Okay, now, so this is like, for example, the packet, the telegram has been generated by the device A. Okay, okay, so this should encapsulate the payload. So this is the payload. This is the actual, the command or like actual the data which the IoT device needs to communicate to the server, right? So how we can able to send the payload? So simply we cannot send this payload, correct, to the network. It has to have the certain supporting the bits, that is, it starts with the start bit frame. Okay, so the bit frame is all about, it is telling that the packet will start from here, right? And then there will be a control. So control is like the data acknowledgement and system. So it is basically telling the system details and acknowledgement and something like that. Okay, this is one thing. And next comes the source address. This is the physical address of the sender hardware. Okay, it is a source address. And coming to the destination, so in this destination, it is a group address. It could be a group address, or else it could be an individual address. Okay, it is telling that packet where to reach, right? So these are all the details required for the router to route it, basically. Okay, and yes, the destination is a group address, or else could be a single address. Now coming to the length, so this length is all about the byte count of the payload. Okay, so it will tell how much the payload is. So this is the length. For example, if it is an 8-bit byte, or like it could be like, it is basically indicating how much the payload is. That's it. Okay, and the last is the checksum. Why we need this checksum? This is used for the error detection. So basically, a validation algorithm. What exactly it will be doing is, the device A will be sending the data. This is the data which has been sent from the device A. Now, while sending in data, so it will give some value. Okay, let's say take an example, 100 value that will be generated based on an algorithm. Okay, same algorithm will be used to check that this value whenever it is received at an receiver's end. Okay, in the receiver's end, same algorithm will be used to decode the value. If the value doesn't match the 100, then that means during the transit there was a drop in some the packets, or like any specific bytes. There might be a high chances that any specific byte might be dropped. Okay, that is one thing. This is all about the checking the data integrity. Okay, now, so if the algorithm matches the value, that is 100 value, with an existing one, the generated one, then that means the data which has been sent and received are the the perfect value, and there has been no tampering or less, no byte drops during the transit. So that is what it means. Okay. And so the payload also can be, and the raw command hexa code, right, for the on and off. It can be a customized one. Okay. Okay. So that is one thing. Yeah. Now let's understand like how actually the packet moves out, right? So as I was mentioning, we need to use the KNX IP for the transportation. So here we need to have the router. Without a router, the device may not be able to communicate with each other, because the router will help us to route the packets to the different destinations, right? Now, so this will be using the UDP packets. Okay. And Ethernet LAN, it can go up to the 1 Gbps, right? And the router can able to operate in the two modes. One is the tunneling mode, and another one is routing mode. What is the tunneling mode? The tunneling mode is a virtual point-to-point connection. Okay. And that is strictly used for an ETS configurations, limited to one connection per interface. Yeah. So basically, this is just the point-to-point connection from the router to any specific network switch, or else any of the server point, right? So this is an tunneling mode. And the routing mode. In the routing mode, it's all about the broadcast, the telegram via IP multicast. So multicast is like the specific IP address. If the router doesn't know where exactly the packets needs to be sent to the destination, right? What it will be doing is it will sending the data to the multicast. So multicast will be sending the the asking different destination about is this specific the packet belongs to your your address or not. So the actual destination will send back the acknowledgement to the multicast, that is to the router, and the router get to know where exactly the telegram or like packet needs to be sent. Okay, that is the routing mode. And now everything is encapsulated, that is by using the UDP, okay, user datagram protocol. And these everything will be standardized by the standard course IANA, and the port what we'll be using is 3671 port. So this is how the KNX we call as net IP frames are reached to a certain destination. Okay. Yeah. So this is all about the complete the backbone, how the bus, the TP bus, which is carrying the data at a rate of 9,600 bits per second, which will be reaching to the router, and router will be sending those data to the destination. Okay. Now coming to the security part. So in the module number 3, we spoke about detailed security in terms of encryptions. We also see the different encryption types, the synchronous, asynchronous type of encryptions. And we also saw how encryption is like very much critical to safeguard our packets when it comes to the hacking, or like a threat actor, which they can able to just snoop into the network and can able to get the system details. right? How we can able to avoid that? By using this encryption. So basically we should never transmit the data in the plain text, right? So this needs to be encrypted. How we are going to encrypt in the KNX framework is by using the AES, that is Advanced Encryption System, uh, that is 128-bit encryption, right? We also have AES 256, right? So that is advanced, but in this specific KNX, we will be using the 128-bit, and this is the military grade encryption, and these specific encryption can able to secure the both local devices, that is the KNX data secure, as well as the KNX IP secure, that is the local as well as the network in the transit. Okay, so in the common words, the data is encrypted in the transit as well as in the rest. If we are saving these data, the both in the transit as well as the storage, these are all encrypted one. Okay, and now the security keys. These keys, right? So some of the devices will come with an specific security where we need to burn the keys within the devices when it comes out of the factory, right? So that we can able to authenticate whether the device are been the good, or else is it an compromised one or not. So this is one thing, and the tool keys, that is ETS password protected one. Okay, and yeah, advanced sequence countering. Okay, this is defeating the replay attack. For example, why this is very much important? So replay attack is like the threat actor try to unlock a door by using the various the methods. One of them is then replay attack. In that, what it will be doing is, so it will the hacker will record a valid unlocked door packet and replay it later. So for example, if we are transmitting the packet, right, to the destination, so the hacker may able to capture this packet, and he can able to snoop inside the packet where we have the destination address, the source address, and the payload. So what he will be doing is, so he can able to use this packet as an authentic packet for the later sessions, so that he can able to hijack or else like snoop into the system and get the information what he needed. So that is what the replay attack is. Okay. Yeah. And the last part on this KNX framework is the configuration part. Okay. So we have one universal translator. So it is called as ETS. Okay. It is an exclusive configuration software for the entire KNX standard. Even though if we are using the different OEM standards, that is, it could be an ABB, it could be an Schneider, it could be any of other smart device sensor manufacturer, right? So we can able to configure those devices by using the universal translators. Okay, we are using ETS in that case. So what is the benefit of using this universal translator is, like, this is an vendor agnostic one, and the different the manufacturer can able to, we can able to configure the different manufacturer equipment, right? One thing, and as I said before, it is an vendor independence one, correct? And seamless logic integration. Now you see here the pictorial representation, right? So whenever if you want to configure any devices, let's say we have the device A, device B, and device C. Let's say this is a device C, right? These all devices are from different OEMs, OEM1, OEM2, and OEM3, and everything can be, so we can able to configure by using this specific the format that is called .knx prod. Okay. So this is the file format. So this we will be dumping in the software, that is ETS software, and then we can able to give certain the parameters. If you see here, we have given the parameters like the physical address. So where what exactly the device, the location, that is physical address. So and the group address, it will help if we are planning for any grouping, correct? And the object can able to switch on, switch off, or else like we can able to do the multiple actions based on our requirement. So this is the scenario, or else like this is the demonstration where we can able to have the different OEM, and we can able to use the single ETS software to do the configuration part. Okay. Now, yeah. So this is very, the bird eye view where we can able to see we are using different options here. Like you can able to see in the multi-story building, we are using the KNX RF, that is to connect to the other devices wirelessly. And here we can able to see the IP backbone, the vertical integration, and for a different devices we are using the twisted pair for the HVAC as well as the power grid. Okay. So this is how it looks. You can able to see these are all the actuators and the power supply units and the couplers. Okay, this is how in the 3D modeling the complete implementation of KNX building management system looks. Okay. Yeah. So let me show another thing which is very much important. Okay. Okay, let's go to the KNX one. So if you are interested, right, so you can able to go to the KNX. Okay, so this is the home page of the KNX. So there is a lot of documentations you can able to find it in this specific page, correct? You can able to see, how the home automations looks like. And if we are going for any options, let's select an architect. Like, so we are planning to design and complete the smart building, correct? So you can able to find most of the details in this section. Okay, there are like many the projects. Also, you can able to get the many project details here, and you can go through those projects, and you can able to design your own use case out of this project idea. So there is different sections, and if you go to the projects, if we are planning for any of the commercial, correct, you can able to select. Let's select an office building. In the office building, let's take an example of this. Okay, and you can able to get the more details what exactly the project is, where exactly the project was implemented, and what is the year of completion, and what the components are used, what were the the sensors, that is lighting sensors, HVAC, or like blind shutters, and operations and visualization, and so on. So energy management. So you will be getting more insights on these specific pages. You can able to look into this, and you will be having more the detailed insight about what exactly the KNX is and why we need to implement this KNX in this era, that is the the building management where the automation plays a key important role, correct? So this is one. So whenever you have the free time, please go through these documents. Okay, and also we have the other details in the applications. You can see we we have we have the heating and ventilation, the security, the door communications, the visualization, and so on. Correct. So this is the home page of the KNX. Now let's see. Okay, let's see the how the ABB and the Snyders are. Okay, you see here if you visit the specific the page. Okay, in the ABB you will be having a number of the tons of details in terms of the building lighting and building automation. Okay, the ABB call it as an ABB IBUS KNX. So underlying technologies KNX, they have built their own product and their own the way of designing the system on the top of the KNX. Okay, here also you can able to see you will be getting the lot of information. Okay, the fundamentals, the features, the application, the installation, and see this is what I was mentioning in the design stage, correct? So the structure of the KNX is where we can able to do it as in linear or the tree or like the hub and spoke method, the star wiring configurations. So so this is how we can able to get more knowledge from the this ABB website. Okay, and coming to the portfolios. So I was mentioning earlier, right? So we need to choose the power supply, the system, the wiring, the room automation. So these are all the devices which are necessary for the integration of complete system, correct? So if you select the specific the power supply, we will be having different the rating of the power supplies, right? You need to choose based on how much the capacity you need based on your design. Okay, just go through it so you will understand. This is an very simple, and you will also find the the tools, the brochures, the training, and so on. If anybody wants to move into the design career in terms of building automation, right? So this is the best place to start with. And this is an industrial standard and the gold standard, correct? You can have this as in handy. Okay, and in the similarly, like we also have it in the Snyder. So this is, if you see the Snyder, call it as KNX home automation. Okay, similarly we have the the different ranges in the KNX. See, yeah, so initially I was talking about the KNX actuators, right? Yeah, so during the initial the PPT, I was mentioning about the actuators. So these are all the actuators which help us in taking the necessary actions, right? So we need to be make sure that we are selecting the actual and the proper actuators and the system configurations, and also you can able to select the KNS sensors, right? So these are all the very famous, the building automation sensors. Okay, the movement detectors. This is for the lighting, right? So if we wants to do the automations, yes, you have to know these the products, okay, and go through the white papers, go through the data sheet of any of the specific the products which you feel, and it is not only limited to these two OEMs. Okay, this is just an example I was just giving, because in the real term, real world, we go into these the OEMs and we will get the knowledge about what the latest product is, how the latest product works, and so on. Okay, yeah. So this is all about the KNX. Okay, so let's talk about the backnet now. Okay, let me close this. Okay, so I was the mentioning about the two important the protocols, that is like the technologies, right? In the day one. So one is the KNX, which we already discussed. The other one is the backnet one. Okay, these two are very important, the protocols. Okay, we'll start in a minute. Okay, so let's discuss about the backnet. Okay, this is also one of the important the technology. This heavily the implemented in the HVAC. Okay. So now, what exactly is the backnet is? So backnet means the building automation and control network, that is called as the backnet. Okay. So this is the globally recognized open standard, the data communication protocol, especially for the building automation and the control systems. Okay. And this is basically developed by the ASHRAE, that is the American Society for Heating, Refrigerating and the Air Conditioning Engineer. So initially, and right now, so it has been uh, you know uh, taken care by ANSI and ASHRAE in the standard 135. Okay, that is one thing. So just to note, okay, what we have. So ASHRAE, that is the standard 135. Okay, and coming to the ISO it will be the 164845. Okay, this is the ISO standards. And the other part, so if you see here, interoperability, that means it is vendor neutral. So we can able to choose the multiple OEMs and we can able to integrate. Okay, right. This is the important one. Okay. Now, similar to the KNX, so even this specific backnet are implemented by many of the famous OEMs. Let's say, let's come to the native backnet manufacturers. So you might have heard about these famous OEMs like the Siemens, the Johnson Controls, and the Johnson Controls and Siemens are the very big players. So they play a major role in the building automation system technology, right? And also the Delta Control, the Schneider Electricals, and the Trans Tracer, and so on. So these are all the native backnet manufacturers. So whatever the device that they produce in terms of the building automation system, right? The most of the cases they will be implementing the backnet. Okay. Now, the coming to the specialized equipments, let's say we have the chillers, the boilers, and the lighting and the power, right? So this, if our use case is on this specific equipments, then we can able to choose the specific OEMs. Let's say for the chillers and boilers, we have the very famous OEM, that is the Carrier and Daikin, right? And the Lutron. So this is very much famous in terms of the lighting and power. Okay. So we are focusing mostly on the lighting and power. Then the Lutron is the best way, the best OEM, I mean, to design the system with. Okay. Now, that is one thing. And yeah, so coming to this, the security integrators. Okay. So for example, we have an Niagara frameworks, the aggregated multi-vendor. So when it comes to the security integrators, it is the access control. And also we have the fire alarm. Okay. So these usually the access control, the door access control, or like it could be any access control, right? So in the backend, the backnet is used as in, the backbone communication protocol. Okay. This is one thing. And coming to the protocol stack implementation, so we have the symmetrics, the KMC control, automated logic, and so on. Now, let's understand how, in the reality, how the backnet help us to understand the equipment, right? The backend, if you see the backend architecture in the fundamentally, so it is object oriented. You see here, it is all object oriented. This is object oriented, right? So why exactly we are utilizing the object oriented instead of exposing the raw hardware data? So this is an hardware, right? So why are we not utilizing the parameters which is directly generated from this, and it could be anything, right? Why are we using this? So because like we don't want to, get all the information out of this devices, and most of the cases these devices will run on the proprietary internal logic. So we may have to work a lot to convert this proprietary into the logic which we desired, correct? So how do we do that? So we need so basically how we can able to do is we can able to do it in the different uh, chunks. That is, we are trying to get the information of the specific devices through the objects and the properties and the services. We are trying to divide this in the real world. Basically, we are trying to enact this hardware into the software part. Okay, that is what it is. So basically, even this specific the backnet is then client and the server model. Server model. Now, what is client? Client is these devices, and the server is where we are running our application. So that will be used to analyze these data, correct? And the communication, the protocol is backnet. Okay. Now, see, so how we are segregating the data. So coming to the data model, so we have the objects, we have the properties, and we have the services. In the object, what information we are gathering, it is all about input and output points. That is the analog input and the binary output. Why? Because the analog, the device, the hardware, it by itself, it cannot generate the binary output. It will be, most of the cases, it will be analog. Then we need to convert that analog signal to the digital one, right? So the input and output points will be analog input and the binary output. And the control logic, it's a loop or scheduled one. And coming to the system management, the system management depends like, the device or network ports and so on. So this is in terms of system management. Okay. And coming to the alarm and events, it's a trend log. Okay. The log part, right? So this is all about the objects. Okay. And coming to the properties, right? What exactly the properties are? Like the properties can have the present value, and it can also have the status flag. So present value, let's take an example about the one transformer here. Okay. So transformer, we are trying to, get the information through the analog input, and output will be binary. And so the present value could be, we are trying to monitor the voltage, the current, the power factor, and so on. And coming to the status flag, whether the transformer is on or off. So that is the status flag. And in that, so we can able to make sure that we get the required information. That is the R that is required, and O is an optional, and the W is the writable conformations. Okay. This is all about the properties. Okay. And coming to the services, so what kind of services we are looking into? So these services are object access. So is it an the read only, the property, these the field, the properties what we are receiving right from the object, whether it is an the read property or else write property, can we able to edit that parameters what we have received, and also the alarm event. Okay, and remote management, time synchronization. So everything is interconnected. Okay, so everything is interconnected. So this is how the data modeling will happen. Okay, right? Yeah. And again, so coming to the protocol stack. So again, if you want to compare to the earlier, the technology, what we spoke, right? And in the module 3, we spoke about MQTT, and we also spoke about SCADA technology, right? And also we spoke about, the KNX. So what is the common between these, right? Even now we are talking about BACnet. Okay, what is the common? So the common thing is the OSI model. So we are adopting this OSI model as in reference, but not adopting completely as it is, but we are refining the OSI model. So OSI models will be having the 7-layer, correct? So we have the physical data network transport, the session layer, presentation, and the application layer. So this is what we are keeping as in standard, as in base. And after that, what we'll be doing is, so we are trying to connect these two. So here, if you see the connection from the OSI model to the BACnet, right? So we are refined in the BACnet architecture. So it is not directly mapped. So we have the physical layer that is for the electrical signals to transmit, and we have the data link layer which is similar to the OSI model, but here which manages the MAC and the framing and the network. It is for the routing between the different networks and the devices, right? And coming to the the application. So application part is where we the session will open between the client and the servers, and there will be a lot of the data exchanges between these the client and the server will be happening, correct? So that everything will happen through the application layer and the protocol handling overheads, and so this is a simplified version, but if you see in the base, it will be an OSI model only what we will be adopting. Okay. Now, so here the topology and the routing technology. So this is very much the bird eye view where you can able to see how exactly the system are integrated with each other. You see here in the bottom. So this is the devices. Okay, this is called as edge controllers, right? Edge controllers. So the local MS bar TP segmentations. So what it will be doing, these are all connected to the router. Okay. These are all the edge devices. Okay. Which we are trying to uh, take the information out of this, right? It could be in different parameters. Okay. Now these we need to connect these devices to the BACnet router, which acts as in the bridging node, right? So what it will be doing is, so it will read the network number and then it will forward that specific packet to the respective destinations. So let's say, for example, we want to reach this specific, the database, okay, the BACnet IP broadcast management devices, which is also known as BBMD, okay, which is required to forward UDP, the broadcast, the access standard for the IT routers. So this will be having certain IP address, this will be having certain IP address, and also this will be having certain IP address when we are trying to integrate the servers and the other devices, right? So the routing will take place in the BACnet routers, okay? And yes, so we will be using the IP subnets and the internet works. Okay, this is how very simple example. Now, coming to the global addressing and the dynamic discovery. Okay, this is one of the key important. So the network and addressing, basically the network number. So we use the 16-bit, the network address, correct? So it will be from starting from 1 to 65,000, right? So this is basically an IP address. Okay, and also we have the MAC addresses. So again, this MAC address, we will not be able to change anything because these MAC addresses are the burn to the device from the manufacturer. Okay. And we cannot able to tamper this. That is one thing. And these MAC address will be unique across the globe. And whatever the smart devices will come out of the OEM, right? Every single one of them will have the MAC addresses. Okay. And that is one thing. And so other one is the device instances that will be having the 22-bit. Okay, it is device identifier. Okay, the combination of these three will give us the globally unique address. Okay. So when we have the globally unique address, we can able to reach out to these specific devices from anywhere from the world. Okay, and so let's say how in devices the device A communicates to the device B. How? So initially there will be an handshake. Okay, this is in serverless discovery, right? So how this will be happening is, so first the device A will send the broadcast signal. So it wants to communicate to the B before directly sending an actual data. What it will be doing is, first it will broadcast the data asking the authentication, like it wants to check who exactly it is, and it requires some details in terms of authentication of specific device, correct? The one which is trying to communicate, right? And after authenticating, because usually in the background we use the CA, correct, to get authentication enabled. And the B, after getting to know what exactly the EA device is and all the required details, then it will send back its response, okay, to the requesting node. Once both are like fine with each other, exchanging the authentication required details and so on, so this will be the communication will be enabled. Okay, this is called the handshake. Yes. So coming to the data link evolution matrix. Okay, this is one of the the key importance. So here we have the two type. If you see, we have the backnet MSTP and the backnet IP. Okay, what exactly is this backnet MSTP? So this is the older the references, like we had this serial connectors, right? RS485. So it will be sending the signal at a very low speed, that is 960 dps up to 76.8 kilobytes per second. It is very, very slow, right? So these are all like we don't see nowadays in any of the design, but in the legacy systems we could able to see these kind of this backnet MSTP, the network which will be utilizing it. Okay, and this is the daisy chain and multi drop buses. Okay, it is very much legacy one, and it only uses the 8-bit spaces. Okay, and coming to the latest one, that is the backnet IP. So what exactly is this? So this is a standard IT Ethernet. Okay, that is based on the UDP. The port what it will be using for the communication is 47,808. And coming to the speed, if you see this, the 960 bits per second up to 76.8 kilobits per second, very much lower, correct? But when it comes to the backnet IP, it is very much higher. Like it goes from the 10 to 1000 Mbps, that is 1 Gbps, correct? So it is very much faster. When we have this higher speed, right, we can able to have the more devices connected to this bus, and we can able to increase the speed and reduce the latencies. Okay. And how the topology will be, like we will be using the IT subnets, okay, to group the devices. So you might have know about the IP subnets, like by using the prefixes /28 /24, and these are all the prefixes what we will be using along with the IP address, right? So these are all the subnets. By creating the subnets, we logically group the devices, and those logically grouped devices can able to communicate with other by using the routers. Okay, and so addressing, yes, as I mentioned earlier, so it will be operating on the IP version 4 and IP version 6, but it will be on the UDP port. So basically, if you consider any of the technologies or the topologies what we are discussing, right? So these part, the standard IP4, IP6, and the port, UDP port, this remain the very much common. So try to understand what exactly these are, and it will really help in the designing process. Okay. Yeah. So here we will be using BBDM, that is like build the management device, wherever like we want to have the communication, right? We saw in the previous the PPT slide where the device, the end device, the edge device is trying to connect to a certain the server. So to overlook this complete the transactions, we need to have the management software, correct? That management software is BBMD here. Now, so if you see here again, we have the latest one. This is the very much latest one, even though the backnet IP is like, the good to go protocol, but the latest one is the backnet SC. So in your exam, so you might be asked about these differences, right? So you might be asked about to write down or design a system by using backnet IP or backnet SC, or like they might ask you about the difference between the backnet IP and the backnet SC. You need to know. So backnet IP, that relies on unencrypted UDP port. Okay. So when we say unencrypted, it is always vulnerable for the network sniffing. Okay. So we need to use the BBMD for the managing subnets. Okay. And yeah, so for now, this specific the backnet IP, it is almost obsolete, and we call that as in legacy. Now it has been replaced by the backnet SC, the secure connect one. Okay. So what exactly is the backnet SC? That is secure connect. So here, so in the backnet IP, it is unencrypted. Here we are trying to encrypt the communication here, right? How we are going to achieve is, again, here also we are utilizing the TLS, that is 1.3, the latest version what we will be using it, right? That is one thing. And the port 47809. Okay. So how the secure connect is established? Because we are utilizing the web WebSocket over the TLS. Either it could be 1.2 or 1.3. And AES encryption, we already know about this, right? So the encryption by using this the 509 mutual authentication, right? And also this the firewall friendly, because we can able to define the port here. And the good part about this the backnet SES, we don't need any the BBMD entries here. Okay, so this is the secured the backnet. Yes. Okay. Yeah. So coming to the system configuration flow. So similar to the KNX, here also we need to have the configuration flow, right? So first we have to do the configuration. Now, initially, in the first step, what we have to do is we have to assign the device instance, the network number, and the MAC address, and the so and so, right? And then the object configuration. What exactly the object configuration? So it defines the object properties, okay, and the parameters. Then we need to do the binding. What exactly is the binding? So binding is the establishing the logic relationship, right? The scheduling the commands and outputs. It is like the binding, the complete the logical relationship between the device and the server. Okay. Now coming to this part, so you can able to see the vendor UIs. It could be on Siemens, GCI, and so on. So what we have to do is, so we are utilizing the generic, that is the open source. Also we can able to do it. We can able to utilize, and the certificates. So this is very much critical for the authentication purpose. So you just have to remember this, like we need to, in the 3 steps we can able to configure. One is the commissioning and the object configuration and the binding of this into the one system. That's it. Okay. Now coming to the the complete design parameters and the limitations. Okay. So whenever we design a system, we need to know the limitations of the technology, correct? So in the KNX, we know that like up to 57,000 is what the device it can able to connect to a single network, right? You see here, it is the massive amount of device. So that goes up to the 2 to the power of 22. So the backnet SC can able to support up to very much larger the number. Okay. And also see the maximum network numbers. So we can able to have even if you see the network 65,535 network numbers, right? So it is an IP, the larger one. Okay, we can able to have the multiple networks so that we can able to accommodate so much number of devices. Okay, and so we use the AWG 18 gauge cable and the maximum up to 1,200 meters. So we need to know about this. Okay, so we cannot able to increase that range. It should be within the 1,200 meters range. Okay, that is one thing. And the typical the APDU size, maximum size limited to the 1,476 bytes. Okay, and the port is 47809. Okay, and it's in memory bonded. Okay, so this is just an pictorial representation of real world scenario. So you can able to see how the edge, that is, from the on premises, we are taking out the data and processing that data in the cloud. How we are going to do that? So let's say we have the physical edge edge right here. If you see here, we have certain chillers. These are all the chillers. It could be a diesel generator. It could be the PLC panel. Okay. So these are all the controllers. And also, if you see here, we have the probes. This is temperature probes, the pressure sensors, the humidity sensors. So there are a lot of information what we are trying to gather from the different equipments, from the devices, physical devices, right? It could be running on different, the legacy protocols. Okay. So everything we are sending that to the aggregation layer. So this is the aggregation layer. So when I say the aggregation layer, it is where the data is getting collected. This is where the data is getting connected. And so here again, we are encrypting. There is no plain text data. We are not sending it, as we discussed earlier. Again, all the data will go here, and we have the perimeter firewall. Okay. In the perimeter firewall, we need to configure the inbound and outbound rules. Okay. So that only, the connection is established. So we have to open the specific port. We saw which port needs to be open in the firewall. And we also have to do the whitelisting of the IPs. So that these devices, right? So these devices can able to communicate to the outside world. Okay. In this, so these device information is transferred to the cloud. Okay. And in the cloud, what we are going to do is we are going to do the analytics. Okay. And it is not only the analytics what we'll be doing and we also send back the command to the system to do the various actions. Now we are sending in command to an actuator to turn off or turn on any specific device, right? So that is remotely we can able to operate it. So this is very much high level where we are trying to get the information from the physical edge to the cloud platform. Okay. And this data can also be used on premises. So let's say we don't want to use the cloud and you want to process every data on premises. That also we can able to do it. For that, we need to set up an data center. In the data center, we need to set up the servers. Inside the servers, we can able to spin up the required application for the backnet. So backnet is just a communication, right? And this application can able to communicate with the device based on this secure connect, the backnet secure connect. And then as per the business requirement, we can able to do the analytics. Okay. So this is how the backnet works. Okay. So just to brief, the backnet is also one of the the well-known the technologies which is implemented in the building management system. Okay. This is very much famous, one of the famous, and most of the part this is implemented in the HVAC and also in the lighting, but majority of the part will be an HVAC only. Okay. And so in the exam you might get the question based on the KNX as well as the backnet, right? So try to understand what exactly these two important technologies are, and also try to read the white papers and try to present some papers to your university, or else try to publish some publish some papers in some journals, right? So it will give you more credibility. So that is what it is. So yeah, so these are all the two important the protocols. Okay, I think that's it. So for the day 3, so I will be teaching which I missed to record, right? So one is HTTP and CoAP, and other one is MQTT. So these three, the communication protocol, I will be recording again. So that will be in depth, where we will talk about how HTTP will be used, and for the larger packets, and how CoAP is used for very low power consumption and quick the communication between the IoT device to the cloud. So this is, and also we will know, we will see how to choose specific communication protocol based on the our requirement. Okay, this will be the day 3 recording. So yeah.